Awe. So let's talk about factorization. What is factorization? Factorization, basically you are trying to okay, let me start here. When you simplify when you simplify something, you would try to expand it and so forth and so forth. It's like you have this number and we are simplifying this whole thing. We're gonna distribute 2 into the brackets and we multiply, so that is expanding, right? So undoing that, to undo that, that is to basically factorize. There's a better definition, but it's just the opposite of, yeah, expansion. Just like I showed here, you have a number, brackets, blah 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 blah. When you multiply all those brackets and you try to get a couple of terms, like one number, you are expanding. But then the moment you try to, that is factorizing. Yeah, but one thing for sure I will say is that, something I'll say for sure is that once you know how to do it mathematically, knowing the definition of factorization won't really matter that much. Um, yeah, so once you know how to factorize, trying to define what factorization is, or trying to know what factorization actually is, it won't matter that much. Right. So let's get started. There are, I think, about 4 or 5 ways of factorizing. Yeah, or perhaps I could say that there are a few things you need to look at when you're factorizing. One of the first one is the first thing. When you see a question that says factorize the following, the first thing you do, is you look for common factors. Common factors are numbers that appear on all your terms, or numbers that can divide all your terms, simply put. Right. Good example, on this number here, number A, you see you have 2, and perhaps let me say this is the same as 2x plus 2 times 3y squared, right? So you see here 2 is a common factor, right? You take it out, then you end up with x plus 3y squared. You see, it's the first thing you do is like, what's our common factor? Then you take it out. Right, here we have something funny. Perhaps I can say we have 5 into a minus 2, and then here I say plus, then I'm gonna have sorry, a number like this, of which you already see these two, they look the same, therefore they are your common factor. You take them out, then what's left is 5 plus b, right? So it's the whole idea. The first thing you look for when you're trying to factorize common factors, you look, for example, here we have 12, we have a, we have 12, we have a, right? So I could say this is the same as 12 times a plus 12 times 2 times a squared. All right, and the whole reason I'm doing this is so that you can see that you have a 12, you have a 12, you have an a, you have an a, right? And now it's even easier. You can say it, but let's take out minus 12a. You will have 1, and then here you will have minus 2a squared, right? Because this is gone, this is gone, right? So that is the first thing. The first thing you look for is, do you have any common factors now? And then after you have checked whether you do have your common factors or not, once, if you have common factors, you take them out, right? But then if you do not, or you have already taken the common factor out, you check a couple of things. We have these things which is called the difference of two squares, which is basically what? There are two square numbers and you're trying to subtract them, right? You are subtracting two square numbers. So this thing, when we actually do it, it becomes a minus b, a plus b. Right, this is exactly, it always follows this way, always and forever. Right, so when we come here, let's think, what's the first thing we look for? Common factor. Do we have it here? Let's look. I think I see something. Yes, we do have it. That means this is gonna be your common factor, and then we are left with 3a squared minus 7. On this bracket, there's nothing we can do. There's no common factor, no difference of two squares. Now, if you want to be dramatic, you can say there is. Right, you can say there is and write 7 as square root of 7 squared. If you want to be dramatic, right, then you will say this is a difference of two squares. But we're not gonna do that, so we're just gonna leave it as 7. Right, so but here we do have difference of two squares, because this 4 can also be written as what? As 2. That means you have a minus 2, a plus 2, 3a squared minus 7. Right, but also I can say, what if then you decided to be dramatic, and write the 7? Let me show you. 7 square root of 7 squared is the same as 7, right? So say you became dramatic and you wrote this as square root of 3 squared. Well, let me put it this way and say square root of 3a squared minus square root of 7 squared, right? So you decided to be dramatic. Then what's going to happen? You're going to have square root of 3a minus square root of 7 square root of 3a plus square root of 7. All right, that's if you decided to be dramatic, right? We can make it into a difference of two squares. You multiply this whole thing, it's going to give you the what you have there at the top. Beautiful. We have another thing that is looking amazing. So here you see there's a square number. Do you see it? It's a square number, and this one also. So we have 6x plus y squared minus 3 squared, right? That means when we factorize this, it will be 6x plus y, right? Then you're gonna have what? Plus 3, right? You have another bracket, 6x plus y minus 3, right? That makes sense, I hope so, because you're taking this one, right? Then there's a plus or minus, right? Then here you will say it's 6x plus y plus 3, 6x plus y minus 3. Done. So the first thing first, we check common factors. Yes, take it out. And then difference of two squares. No. Then we go to the next slide. But then if you don't have a common factor, check difference of two squares. If yes, you do this. If not, you go to the next slide. Let's see what's on the next slide. There's a factorization by grouping in pairs. So this one, how does it work? This one, I have put it in order, so we don't have to do any rearrangement. We already see we have 2, 2, we have 3, 3. So it's perfect. And even it's all pluses. There is no minus, so which makes it even more perfect. So here, you're going to group 2x squared plus 2x plus 3x plus 3. Take out common factor in each bracket. Here we have 2x as our common factor. We are left with x plus 1. Here we have 3 as our common factor. We are left with x plus 1. Then we have another common factor, which is x plus 1. And then we are left with 2x plus 3. Ne? We continue to work on the next one. Here's what is beautiful. So I'm already seeing I have a y, I have a y. Ne? I have a b, I have a b, I have an x, I have an x. So I need to decide how am I going to group this. Ne? But also I'm seeing I have a 7 and a 14, right? So perhaps I can just leave them as they are and say I group 7x plus 14y. Then I say plus bx plus 2by. Common factor here, 7. Then I have x plus 2y. Common factor here, b. Then I have x plus 2y. Then I have common factor. Then you have x plus 2y, 7 plus b. Right? Done. I just wanna test a different way of grouping it. Ne? I just wanna test a different way of grouping it. Say I group it with so this xx and bb. Ne? So I have 7x plus bx plus 14y plus 2by. Common factor here, x, 7 plus b. Yes. Common factor here, I have 2y, so 2y. Then I have 7 plus b, right? And then I have common factor. So I start with it, 7 plus b, x plus 2y. Do you see it? So you choose, like certain problems they differ, ne? Like in terms of which pairs you can take. Let's test with this one. Let us test with this one to see if the pairing thing we can, but I don't see how, because okay, let's say for some reason I group this one as 2x squared plus 3x, right? This is the first group, plus 2x plus 3. Ne? Common factor here is x, then I have 2x plus 3. Then common factor here, 1, then I have 2x plus 3. Common factor, 2x plus 3, and then x plus 1. It works. Do you know what I mean? It works. Let's come here. So here we're trying to group, of course. You see y. You also see this x. So maybe let's start with the y's and say you have 5. What a beautiful 5. xy minus 3y plus 10x minus 6. Common factor here, y, 5x minus 3 plus common factor here, 5x minus 3. Common factor, 5x minus 3. We are left with y plus 2, right? Let's try a different way of grouping. Ne? So we grouped, of course, with the y's. Let's go with the x's now. So you have 5xy plus 10x. It's the first group, plus minus 3y minus 6. Common factor here is 5x. So you have y plus 2. Common factor here, minus 3. So you have y plus 2. Common factor, y plus 2. 5x minus 3. Exactly the same answer. Let's see what we have next. Let me see. Alright. Cool. So yeah, we were doing factorization by grouping in pairs. So now the fourth one is you have a quadratic trinomial. Trinomial is an expression with three terms. Ne? So here it's quadratic because of that x squared, and we are trying to factorize it. There is a beautiful method that I'm going to show you. It works everywhere. You don't have to overthink it, especially even when you have coefficients here and your coefficient is not even a common factor to all other terms. It's gonna work very, very beautifully. So the first step, step number one, you multiply coefficient of the coefficient of x squared. You multiply it with the last term. So you have 3 multiplied by 1, which is what? 3. Focus on 3. What are the factors of 3? It's 3 and 1 multiplied together. So when you write these factors, you write them in pairs. So you only have one pair here, which is 3 and 1. For 3 and 1, is there any way in which you could add or subtract them such that you're going to get positive 2? The answer is yes, there is, because 3 minus 1 is positive 2. So now, okay, let me write it. 3 minus 1 is positive 2. So now I come here, I'm like 3x squared plus 3x minus x minus 1. So now focus here. When you look at that, you see it is exactly 2x. We didn't change anything, and it came from here. Ne? Cool. So now we're gonna do what we have just done now, which is grouping in pairs. Ne? So cool. You have your first group plus your second group. Taking out common factors, we have 3x x plus 1 here minus 1 x plus 1. You have x plus 1. You have 3x minus 1. Cool. I hope you guys understand. But if you don't understand, let's repeat it again. Step number 1. Coefficient 1. Multiply the coefficient by the last term. 1 multiplied by 8 equals to 8. What are the factors of 8? You write them in pairs. 8, 1, 2, 4, 5, 6, 7. This is them. We only have 2 pairs. From these 2 pairs, the question is, is there a pair that you can add or subtract that will give you the middle term, which is 9? You look at the pairs and you look at the numbers that could possibly give you 9. And yes, there is. It's 8 plus 1 equals to 9. Do you see it? So therefore, you take it. Yeah? You have x squared. And be careful also, like when you group them, you want to make sure that you put them properly, in a sense that you don't want to create more problems for you. So I'm gonna start with x and I'm gonna end with 8x plus 8. I'm ending with 8x because I have 8 here, so this will just be a group, this will just be a group. So you group them, x squared plus x plus 8x plus 8, right? Common factors, common factors, common factors, x plus 8, and you are done, right? So with that being said, I want to say wabona whenever your coefficient of x squared is 1, cool, whenever your coefficient of x squared is 1, this is the simplest way you could do it. Just open your two brackets now, and then you put x here. The numbers, the terms, all of them, they are positive, so that means it's gonna be positive all over. Then you think, are there any numbers that when I multiply them I get 8, and when I add them I get 9? Yes, there are. The numbers is 9 and no. The number is 1 and 8. I multiply 1 and 8, I get 8. I add 1 and 8, I get 9. So that means you have 1 and you have 8. Right, hopefully we get another example like this, so that I can illustrate this. Right, beautiful. You don't have a coefficient of 1, so let's do that method. First thing first, you multiply, so 1 multiplied by 7, 7. Factors of 7, 1 and 7. Any numbers, any pair that can give us the middle term, yes, there is. If I say 1 minus 7, the answer is minus 6. You see it? So cool. So now, of course, you see the 7 here, I see the 7 here, so that means I'll say 7x squared minus 7x plus x minus 1. Right, we group them. 7x squared minus 7x plus x minus 1, common factor, x, common factor, 7 plus 1, and then you are done, just like that. It seems very simple, né? That is because it is very simple. So we have another one here. Question number 1. Any common factor? Yes, there is. What is that common factor? It is 3. So we take it out. 3. Then you have what? You have b squared plus 5b plus 4. Right? Because 3 times 4 is 12. Right? So now we finally, now your coefficient is 1. Ne? Your coefficient is 1, therefore you're gonna do 2 brackets. Then you have b, everything is positive, that means you have positive. You think of two numbers, you multiply them, you get 4. You add or subtract them, you get 5. Yes, there is. It's 4 and 1, so 1 and 4. You multiply these two, you get 4. You add these two, you get 5. Do you see how it's done? But I will take this and I will put it here, and let us try to do it with that long method, just to test it. 1 multiplied by 4, 4. Then the factors of 4, 1 and 4, 2 and 2. Any pair that gives you 5 when you add or subtract, it's this one. So that means you have b squared plus b plus 4b plus 4. You group them, common factor, you have common factor. What's left? And it's exactly what we have over there. You see it. Now let's see what we have next. All right. Okay, cool. So here we have something really beautiful. Before we factorize this, I want us to multiply these two numbers. Yeah. So let us go on. You have x into x squared minus xy plus y squared. You have plus y into x squared minus xy plus y squared. Then you have x to the power of 3 minus x squared y plus x y squared plus x y squared minus x y squared. This is actually x squared y, and then xy squared, then plus y to the power of 3. I'll just recheck to make sure I didn't make a mistake. X to the power of 3, and then x squared y, xy squared, yx squared, y squared x. Cool, everything makes sense. So now I can start with this to say I have x to the power of 3 plus y to the power of 3, and then the ones with the x squareds, look at them. This one is plus, this one is negative, 0. Let's look here, plus, negative, 0. That means this is my answer. You see it? So before I say anything, let us pause. Okay. We have another bracket here we're going to multiply. Okay. So let's do that. X into x squared plus xy y squared minus y x squared xy y squared. So you have x to the power of 3 plus x squared y plus x y squared. Then you have minus x squared y minus x y squared minus y to the power of 3. Just like before, I'm going to start with this one to say you have x squared x to the power of 3 minus y to the power of 3. And let's look at others. The one with x squared, negative plus, so they cancel out. It's gonna be 0. Let's look with y squared, positive, negative, 0. Do you see what's happening here? We can then conclude that, conclusion, we can say x to the power of 3 minus y to the power of 3 is equals to x minus y, x squared, xy, y squared, and then x to the power of 3 plus y to the power of 3, we can agree x plus y, x squared minus xy plus y squared, right? I'll just check for verification. X squared minus xy, yes. So now when you have something like this, a cubic number, whether it's a difference of cubes or summation of cubes, right, this is how you'd factorize them. And one way in which you could memorize them is, let's take a look. So for the difference, okay, before the difference, just take a look. The first bracket, or your binomial, your binomial bracket is, in the structure, how it looks is exactly the same as the expression you're trying to factorize itself. So you see you have x minus 1, we have x to the power of 3 minus y to the power of 3. So that x minus 1 is still there. Look at this one, x plus y, then x plus y. You see it, and then let's look, the one with the negative sign is only here, right? It's because we just literally copied the side. But then On this other side, everything else is positive. I'm sure it's very easy to remember x squared plus xy plus y squared. All you need to remember is that the signs are positive. But the one that is all positive, this one, right? This one, you have a minus here, right? Here, here. This one is always positive. So here, always positive, always positive. The only difference in terms of the signs is this one. If it's negative here, it's positive here. If it's negative here, it's positive here. If it's positive here, it's negative here. Do you see it? Cool. Let's see if we can handle these problems. Yeah? We have x to the power of 3 plus 8, which we know to be x to the power of 3 plus 2 to the power of 3, which we have shown. Let me take it up. We have shown that this you're gonna have x plus 2, right? And then you're gonna have x squared, then minus, then it's a multiplication of these 2x, and then plus this squared, which is 4. Do you see it? And now let's look at this. Can we factorize this bracket? Ne? So you guys know the longest way I've taught you, which is cool, right? And I've also tried to show you guys the shortest way also. When we say you have x, since it's a negative, one of them will be plus, one of them will be a minus. Ne? So now you look, are there any two numbers when I multiply them? I get 4. When I add or subtract, I get 2. So you look, 4, 1, 2, 2. There's no number that gives me 2 when I add or subtract in these pairs. That means the answer is going to be just up until here in terms of factorization. Is that clear, ne? Yeah. Let's check. It's x plus y, x squared, y, x. Everything is fine. Everything is fine. Let's come here. Beautiful, beautiful work, beautiful work. So here, I don't know what this number is. I don't know what it could be. Ne? But I know 4. I know 2. Okay. Let's see. Okay, can you? 2 times 2 is 4. And then 4. Okay, basically I'm trying to say 8 is 2 to the power of 3. Yeah? And then 3 to the power of 3 is actually what is it? It's going to be 27, and that's not 27. Cool. So here I'm getting bigger numbers. I'm gonna need a calculator. Yeah, I'm going to need a calculator. But so I have a calculator here. I'm working with big numbers here. Yeah, so I want to say, while I was getting the calculator, I realized something. I did a very, very big mistake. And my mistake was not to ask the question that I should have asked, which is, do we have a common factor? That is always the first question. Before we try to do anything, the first question, do we have a common factor? And apparently here we do have. We see 16 here. So if we go to our calculator and say 432 divided by 16, look at what we have. We get 27. Right? So that means here, the first thing that you will do is you will say this is the same as 16. Then y to the power of 3 minus 27. Which, of course, now what you have there is, highly doable. Let me say you have minus 3 to the power of 3. Right, we can check it. 3 to the power of 3, 27. So then the next step, it's gonna be y minus 3, Then you have y squared, it's negative here, that means it's plus. Then you have 3y plus 9. You are done. But maybe before that, you can look at this. Are there any two numbers that when you multiply them, they give you 9? When you subtract or minus, they give you 3. We don't have such numbers. Oh my god, we don't have such numbers. That means we're gonna leave it here. This is the end of our factorization. And then here's another number. Let's try to factorize this one. So for this one, first thing first, do we have any common factors? Apparently we do not. If you can look at these numbers very well, we do not have common factors. But what you can do here is you can say you have 2t all to the power of 3 plus 5p all to the power of 3, right? And once you have done that, it becomes easier now, because you say 2t plus 5p close bracket. This is your binomial. Then the second one, it's gonna be the squared. 2, it's gonna be 4t squared, right? And then it's a plus, therefore minus. You multiply these two, you get 10pt, right? And then plus 25p squared. And then you are done. Just like that. Yes, so this is the end of factorization. Yeah, so we have the sum and the difference of two cubes. We have this factorization of quadratic trinomial. We have grouping by pairs. We have difference of two squares. The most important one is taking out the common factor. Yes. So guys, I'll see you on the next video.